How we do machine learning for grown-ups. As grown-ups, when we do machine learning, we do not produce notebooks. We do not produce PowerPoint presentations. Aside of the joke, which is not meant to be totally a joke because it has some truth behind, I like to think about machine learning like sometimes we do not think about machine learning like that. But 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 I think machine learning is software engineering. When we do machine learning as a grown up, we output something which works automatically aside of um, a lot of human intervention. Mm, Sometimes machine learning is thought as something fundamentally separated from software engineering. But aside of the jokes and this fake bitterness, let me fully disagree. I think there are trend that it feels uncomfortable to me. It happens because of the democratization of machine learning and data science. Again, difficult topic, the mixture of these two titles, of these two keywords. Um, without getting far away from the tangent for this introduction, um, I think, and I felt in my own body, that the distinction between these two disciplines has brought more pain than any, more pain than gains. Mm, but there are some differences. But for sure, machine learning engineering is engineering, and engineering uh, is applied science, and we do from engineering uh, we do not avoid or um, take science as something not useful. On the contrary, is the foundation. Science is the foundation of engineering, but engineering has a different outcome, a different expected objective, which is some kind of an application. So when we do machine learning, we expect to get as an output of the work some kind of functioning thing, like let's say, for instance, a REST API or 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 a batch thing that batch process that's that produces results periodically. Um, no matter if it is controlled by a cron or a cron job, but has to produce some output in an industrial way, in an industrial manner. And definitely, PowerPoints or notebooks are not the output of them. This happened as well because sometimes I think it happened because of the democratization of machine learning and data science, uh, which obviously surface the dilemma of when you get something more widespread, you stop living in the cherry of the cake, and mm, you get involved people where lower and lower degrees of sophistication or performance. Um, but in the other hand, you get a lot of a wider volume, Yeah, it's the typical trade-off between quantity and quality. Mm, but I think maybe because of the impressive development of machine learning and data science and the disciplines for revolving around artificial intelligence, they have had a massive development during the last few years in terms of, well, in 2010, um, it was pretty hard to feed a logistic regression model on top of a few thousand records, in both in terms of computation, hardware, and in terms of human skills to develop and deploy the code. But things get much more easier today. For instance, I like to think about the transformer library from Hugging Face. It makes stupidly easy to feed a sophisticated natural language model, which a few years ago it was something unimaginable, or maybe restricted to a handful of top researchers. Um, Now you can do it reasonably well with a few lines of code. So that is what happens with the democratization of machine learning, and that it's way easier, but you get people with very little knowledge and skills jumping into the field, um, and that is a risk. So about that is, I think, one of the fundamental things that thinking about these disciplines as non-software engineering, because the software engineer entry barrier is no longer there anymore, but just for the casual visitors. But if you want to do something working, do something solid, a good a product with with, with solid functioning and very good features, you cannot stay in the lobby, and you need to rely on software engineering because at the end you are dealing with software engineering product. From the general to the specifics, what does the specifics look for machine learning for grown-ups? I start with some with some issue that looks like very contrarian to most of the things that I see around, and is that you should be thinking about things like, for instance, object orientation. Object orientation is commonly thought as something for backend developers or something like that. Machine learning engineer shouldn't be thinking about that, but I think it's a very powerful tool, and I think it's the way to go. And from my experience, is what allows you to handle greater levels of complexity uh, in order to develop a properly functioning system. So object orientation gives you um, gives you the chance of modularity, of composability, of inheritance. Um, these are software engineering principles that keeps on applying in the domain of machine learning engineering as well. Not as machine learning engineering field where something unrelated and from another universe, because as I once more say, it's software engineering in the end. And sometimes we think about object orientation as a means to repeatedly and massively create instances of objects with specific properties. And for machine learning engineer, it's not always the case because most of the times we do records in a table and things like that. But um, machine learning system, we got pretty standard structure, which is probably not useful to, di- to, to divert very much from it. Which is, for instance, we got a component of the system which does data ingestion, and component of the system that does data processing. And on top of that, we got feature engineering. On top of that, we got algorithmic uh, fitting of supervised and supervised models, things like this. We got the model itself, and we got evaluation, and we got deployment. And it's very uncommon, and probably you are not um, properly thinking about the system that you are handling if you divert very much from this very common structure. Object orientation, just for the sake of conceptual modularity of the system, could wrap this structure in classes, not just for, as I said, for repeatedly created instances of them, but just for logical separation, for compartmentalization of these pretty standard domains and parts of machine learning systems. The anti-pattern for this, or the contrary to this, is uh, we get a main uh, um, and a set of statements, one on top of the other. So we got like a 1,000 line main function where we do all of the steps that we want the model to do. But this pretty easily and very quickly becomes mentally unmanageable. And I'm focusing on mm, the, the, the mental workload instead of the maintainability, which is the common topic and the common approach for this modularization of the code. Because it's not only for maintenance, because at the end, maintenance, uh, in my experience, is something that at the end happens for very short times. Because when we face a project, uh, mm, we evolve it for a little time, and very very quickly, in a very short amount of time, we start thinking about doing something totally different. So maintainability is most of the time something that it does not happen. Instead, you break things apart and start from scratch again, and that is the way you evolve most of machine learning systems I've been interacting with. Is not this uh, these systems have a very short lifespan. Instead, when we evolve them, we kill them mm, and give birth to a new version. So it's not for maintainability; it's just for handling the complexity through uh, logical um, separation of units. So things get much more easier to create uh, complex structures on top of your initial version. So object orientation, it seems crazy, but I think it simplifies a lot um, machine learning systems and machine learning development. We do not produce notebooks. We can use notebooks in machine learning, mm, but we do not deploy notebooks. We do not maintain and version notebooks. Notebook is not the backbone of a machine learning system. If you want to sleep peacefully every night, mm, I think they're very useful. If I confess myself that I use notebooks from time to time, Mm, but only for a purpose, and it's for displaying results. They're very good for displaying results, for showing top level functionality of your code, exposing only the top level statements, the top level operations next to their inputs and outputs, and to provide uh, something which um, even machine learning engineers, not only data scientists, had to do very frequently, which is get a conclusion and get some insight about how to approach machine learning problem. Uh, so we can get to the bottom of of, of the problem to fully understand it. We want to demonstrate how a machine learning model uh, interacts with some data. What is the input? Where is the output? And um, by the way, few things that I always do for notebooks. Um, I expose only top level functionality because I don't want to develop in the notebook. So the notebook inherits and imports the models uh, that I develop aside, and I just take the top level functionality because it's not meant to show to display the internals and the details of the implementation as well. It's not meant to duplicate the code, and and the other thing is that I always start the notebook with a hidden cell, with a head, I mean a heading, where I place a dedicated and detailed intro with objectives, highlights, uh, and important definitions of the data. I usually uh, place some notes about the approach, the algorithmic approach itself, and some notes where I place whatever I found and want to keep track of it. So I force myself to do this because I want to think about notebooks, about something to demonstrate the findings and the top level conclusions of a machine learning system to someone else or to myself at some other point in the future. And this is just like mental exercise in order for you to make sure that you fully understand the problem and the consequences and the approach. Um, so that's the way I use notebooks. Again, the anti-pattern for this, the thing that when I look at it, it results me in the ugliest of things is um, placing uh, cells on top of cells until you get a number. And in the ideal case for the anti-pattern, uh, this um, this number that you get finally, the metric, the AUC or the accuracy or whatever, it only happens if you execute the cells of the notebook in a particular order, which is not the top-down order. So, well, this is just for the ugliest, but I think it's much more common than what we want to assume. So I've seen disgusting things as well, like git diff for notebooks. Who wants to maintain a notebook? It's a one-shot thing, snapshot of the functionality, the implementation, the results, and the knowledge about the problem itself. Um, it's not meant to be maintainable. So git diff for that, it's an oxymoron. It's something ugly. It's disgusting when I say it. And yeah, I feel free and better if I tell it. And what else? What else to say about this? Um, Obviously, the outcome of machine learning practitioner is not a PowerPoint or some slides. Um, if you are doing that, and that is what is requested by you, is because there's no true necessity for the solution. It's just some the regular corporate need to justify um, effortless work and budget. So, so we can keep managers discussing about things that they're not fully working, but we do not have the objective or the need to make them fully working. We only want to justify uh, the session for the next demo sprint and things like this. So yeah, let me rant about that, but we should because it's not the way. Um, what else to say? Well, I guess too many. I would like some contrarian things as well, like test-driven development. Um, that is not for developers. That is not for backend people. That is not for software engineers. That is for um, projects which involve software engineering and things that should expect it to happen. Uh, the tests are an API. It's a test is a contract. So given this situation, I expect this to happen. And that is the idea case, for instance, um, for feature engineering. We will want to parse data, raw data, and do some transformation, some cleaning. We want to expect some things to happen, and we want to keep them controlled in the test. Again, not only for maintainability, but for clarity of the development, for clarity of the understanding of the problem. Because for sure, the requirements and the things that we expect from the code, like in every other problem, um, is maybe it's not the most important thing, the answer, but the question. So the question is the test that we implement. What is the thing that we want to happen? What is the thing that we should be putting attention on? Um, and, is, and that is supposed to evolve across time. The deeper we understand the problem, the better the questions there are, the better the test that we expect the better the test that we impose to the code. And it's not as well. It's not only for maintainability or for freezing functionality. It's about specifying our understanding about the problem and translate it into code instead of vague words or even ideas. So test-driven development is great. Is wonderful for that purpose. Mm, as well, test-driven development is very useful because machine learning keeps us keeps the machine learning product or project modular enough. That is key for speed of iteration in machine learning. Some if for developing for checking a functionality or a modification in the system, we need to run the whole thing and check if finally we get an area under the curve again. Maybe the iteration cycle gets very slow. Instead, if we force ourselves to um, to comply with the unitary tests, uh, that is a way to force us into modularity. So you can check um, specific parts of the code, um, implement them separately, and that is key. This is paramount in machine learning because sometimes the workload, the whole run of the system is way too heavy. Um, it's impossible to iterate quickly in the implementation and the development of the machine learning system. We need to check every single change against everything else, because machine learning is the worst place to do that. So instead of thinking about machine learning as a place where not to apply tests, I think the contrary is where probably it's more useful because of these huge workloads that are involved in slowing your iteration cycle for development. So I found that it seems very strange that test-driven development is something which does not apply to machine learning engineering things. Maybe this could be a whole topic, but I like to work in problems. I found that this the most useful approach is like a meta thing for approaching problems is trying to solve problems backwards. I mean, from the solution until uh, from the solution backwards. Let me illustrate this. For instance, when I was studying school physics, this kind of maybe the parabolic the parabolic trajectories in physics. Uh, it was very helpful to me to think about how does the solution look like, and then try to find it backwards, trying to add in the steps. So you start by stating very clearly what is the final outcome, what is the final variable, the final unknown that you want to figure out and to calculate, and have an idea about how it looks like. It is positive, it is negative, it is near to zero or near to 1,000 meters, things like that. Not only the shape, not only stated clearly, but trying to say, okay, around this value, about it, the value should be around this band, um, and build backwards. You start, okay, where I can get this unknown, where can I get this variable? You look for the equation. You look in the equation, where do I need to discover what variable is missing in this equation, and try to look for the questions that drive you to the result for that intermediate result. And and you go back to the statement and okay, this is my starting point, and now I know the path, and I know how the solution looks like. How is the I know a lot of about the destination, and I have it clear in my mind where this should be leading to. It happened to me um, way before that with mazes and labyrinths, the kind of my daughter does right now. Simple labyrinths that you see in a workbook. Um, I found it very easily, much easier to solve if you start from the from the destination and go back to the starting point. Because if you start from the starting point, you get to a lot of dead roads and roadblocks and things that you get stuck into. Um, and it's cheating, I guess, starting from the end, starting from the destination. But here, there's no cheating here in trying to figure out a machine learning system. How do I like what is the final outcome? What is the final prediction? Um, let's start from that. And there's no teacher here evaluating us and saying, okay, you are cheating. On the contrary, it's more efficient. So I mean, you start building, you get a machine learning problem, and you start thinking about, uh, wait, a great neural network which has a great accuracy, which trains across a very big cluster with tons of nodes and parallelize and distributes workload like a charm. And maybe you do that, for instance, with the Spark machine learning library, and you train off several million records or slightly fast, and then you go to okay, that is the we almost got the problem, and then you go to serve in a REST API, and you need milliseconds for these predictions to be served, and you realize that the Spark is not meant for that because it depends and relies on Spark context, and it's not real time, but it's near real time. It works with many batches, and you found that you are never going to get to the 4 milliseconds latency for predictions. You say, okay, it's 2 months of work, and they go into the rubbish bin. That is not the place. That is not the way to work. So, on the other hand, if you start backwards, like if we do back propagation, you start from where you go to where you want to reach to, and you look at the gradients and where are the paths that are leading you there quicker. That is a much better way of working, not only for machine learning but for everything. So you start with the API and you build a very simple and stupid API with maybe with a rule-based model, and you start building the system on top of that, uh, and then you go back to the beginning, so to the feeding of the data and to the training of the model. But now you have connected the destination and the starting point, the outcome and the input. And then between these 2 points, now that you have got like a like a rope bridge or like a provisional bridge, you can start adding things, start improving parts and seeing where are the bottlenecks and where are the most critical things in the path. Um, maybe you think that maybe you see that uh, doing a different training or training with a specific framework um, allows you to serve the predictions in time, and you see all along the process you are aware of the roadblocks and the dead ends, and that is one of the good things, working backwards towards the solution, from the solution to, to the starting point. And I found it very useful. Mm, there's some other thing that I wanted to mention as well, machine learning. Um, and this goes better into this bucket of avoiding hype. And I got this probably the clearest that I hear this uh, from, uh, from another person is Andrew Ng. Andrew Ng, it's a celebrity of machine learning, and he always advocates for um, mm, data-centric approach versus model-centric approach, and that is almost contrarian because of the success and deep learning and XGBoost and all these frameworks and models, which are super efficient and uh, don't take me wrong, uh, they're they're wonderful, but it somehow eclipses the idea of feeding the proper data, not throwing the kitchen sink into the model, and use the idea is that the model could improve metrics and in the 1% range. But data and the right amount of data and the right records and the right approach to data uh, is the one who is the one providing um, increases in metrics in the in the 10%, in the 20% range. The significant increases in performance most of the time comes from different approaches in data and how we deal with data. And well, there's massive uh, field behind that. We got some things like active learning for looking at which are the most useful data points for the model. Um, yes, to think about the worst case scenario, which happens very frequently, is that where many times we are simply feeding models with duplicated records, which is most of the time a stupid thing and a waste of computing power and developing time. And probably that does not make any sense most of the time. Feeding duplicated records. So the idea is to feed the model, feed the model with the best data that we can, and maybe we are meant to. Maybe the best outcome sometimes is to simply discard data because they're mislabeled or they are um, um, confounding the model in some obvious way. So instead of improving the model, we need to look into we need to apply error inspection and see why is the model failing and what is the why is the model failing in this case, and maybe we can look into important insights which help us addresses the data in a way different manner, which has potential for improvement way higher than maybe adding more layers into a neural network. And I think that as a contrarian view as well, many times. And I think as grown-ups, we should take a look into the fundamentals of machine learning, the BC dimension. Say, okay, does my model need more model? Does my machine learning system needs more model, higher complexity, more layers, greater number of trees or iterations? Or is my model needing more data or less features um, um, or less biased data? When you go back to the fundamentals of BC dimension, trade-off between bias and variance and or fitting versus generalization, um, that is that is the kind of knowledge that guides you uh, towards the next step in the development of a machine learning system. And it's not always the answer to improve the model, to make the model more sophisticated. Sometimes it's just the contrary. Sometimes if you look into this kind of knowledge, the conclusion is that you should be looking at data in a different manner and maybe not only adding features, because many times we think that the more features we add, uh, the more aware the system and the model is about any possible patterns, and maybe you are simply overfitting, saying that next week it will rain on Tuesday because we found that day of week is a very important feature for predicting rain, and um, that is that is for me the clearest the way to thinking about overfitting, thinking about raining on Tuesdays because your data says so. So that is the kind of question that a data-centric approach is sometimes the conclusion of and many times and frequently is the conclusion of a study, the VC dimension and the trade-off between um, bias and variance and the complexity of the model versus the volume of the data set. And if you want to do machine learning as a grown up, I would say that keep this always in mind. And a few more things that I wanted to say, but very much because we could ranting about all these things that pieces us for so long. But mm, one more topic I'd say before closing is sometimes you are not creating the machine learning system. Uh, I found many times that there is a previously designed and sometimes implemented, sometimes deployed, and sometimes money depending on the well functioning of this system, and you do not like it at all, and you need to iterate or to maintain or to scale or to make a development into a ongoing machine learning system. And sometimes we got these Frankenstein um, machine learning systems which seem ugly uh, at each part of them, and uglier when they all the parts are together because it's been uh, being refactored and developed on top of previous people work and people coming and going, and mm, the company taking different directions, the problem being uh, better understood as the problem as the system keeps evolving. So the older parts seems totally wrong, but it's not easy or it's not safe to change them or to discard them. Um, but yeah, it's sometimes it's not only about building; it's about reforming what it's already built, and that is hard work as well. So my experience there is there are some obvious things most of the time that you can see that they're uh, functioning wrong in the system, and you, the more you develop machine learning systems and the more you are experiencing this, you develop an intuition about where are the critical points. So um, well, this is not an idea of mine, and but I definitely feel very inspired by Elon Musk and this first principle thinking and the idea of uh, mm, taking his philosophy. Uh, you enter the system and you say, okay, why is this in place at all? Instead of optimizing it, you question the very existence of part of the code which seems ugly, and the idea is try to make surgery changes, um, the places which looks the more stinky and they are reasonably um, low risk, and they have a great potential for doing an actual improvement. Improvement could be in terms of metric of the system, in terms of um, making huge tons of a great share of the computation redundant and not being made again, because maybe we do not need to process like a table that happens somewhere else and we're not using these features at all or something like that. So alleviate this. So they or maybe we got a for loop with an ensemble of models which they're not clearly necessary each of them, and okay, this is This is an spaghetti code stacking a lot of models, and we do not even know why they are needed at all. So let's think about remove them and replace it by something simpler. So my idea is, my what I found useful is try to look for where to reduce complexity. And instead of adding solutions on top of that, or adding fixes, uh, that is probably the wrong direction and what led the project to an ugly state as the current one. And instead of patching and adding fixes to things, and let's see what is possible to be discarded, what complexities are possible to be removed, and lead to a more simple version of the system itself. The ideal case is try to understand what the system is doing and say, okay, it's fine, guys. We learn a lot building this, but this is a liability now for the company, and it's better to build it up from scratch and use the system just to provide the knowledge about the problem, and we can create with this hardly acquired knowledge and the recent developments and the new tools that we have now that we hadn't 5 years ago when this was built. Put this together, the new tools and the hardly acquired knowledge, build it again from scratch and live a happy life there. And that will be doing machine learning as a grown up. Uh, and I wouldn't say it's easy, and I wouldn't say it is not scary or risky, and I wouldn't say it's for every place and for every time. But that's the ideal scenario. Yeah, those are a few things that we can think of for doing machine learning as a grown up. Um, um, we always, just like the kids, want to be grown ups. It's and when they are grown ups, they start to feeling nostalgic about when they were just naive and life was much easier. Um, your universe was more smaller and simpler. But who do not want to go farther and feel more powerful? And yeah, for me, the light here is simplicity, clarity, and on on top of the code is not the most valuable thing. Knowledge is superior. So as we were saying at this last part, um, when maybe the less valuable thing about the machine learning system is the code, but the knowledge that we acquire to understand and to tackle with the problem. So knowledge and simplicity are paramount and the best things for behaving like a grown up, and especially here in machine learning for grown ups.